Now I'm going to show you a demonstration of some of the features of Python that shows how big ideas in the course will fit together. In this demo, I'm going to use some features of the language that I haven't really described to you yet. So it might not all make sense right away. But if I had waited to introduce each of these features before doing this demo, I wouldn't get to a cool demo on the first day. And we've got to do something fun on the first day. So here we go. Don't worry if you don't understand every detail. I'll start out by starting the Python interpreter. There was an author. His name was Shakespeare, and he wrote many plays. I just opened them all, and in order to get the text of those plays, I'll read in all of the plays that he wrote and split them up into individual words. So text contains all of the words of Shakespeare, and the first 25 are A Midsummer Night's Dream, that's the title of the play, and then the text, Now fair Hippolyta, our nuptial hour draws on apace. 4 happy days bring in another moon, but oh, yada yada yada. Shakespeare. Really an impressive body of work. How impressive? Well, there are 980,000 words of Shakespeare. That's a lot. Okay, how impressive is this really? Well, it turns out that a lot of this text is just the word the over and over again, 23,000 times. Seems less impressive now. He says other things many times as well. So what's a classic Shakespearean word? Thou. Thou, 4,500 times is how they said you back in the Shakespearean era. In fact, did they say you at all? It turns out that they said it 12,000 times, more than thou. What else does he say? Forsooth, 40 times. What do you think is the most common word in this text? Well, it turns out splitting it up in this particular way, A Midsummer Night's Dream, now, comma, fair Hippolyta, comma, we see a lot of commas. How many? 81,000 commas. That's 0.083, or 8.3% of all of Shakespeare is just commas. And another big chunk of it is just the. Well, it's actually that the words in between the commas and the thes that make Shakespearean plays and poetry very special. So let's learn more about those words. One thing we can do is just look at all the words that exist in the text. And to do that, we'll create a set. And we can find that the set contains the word forsooth. And it also contains the, as we saw. How many different words does it contain? Well, not 980,000, because words has no repeats. And there are only 33,505 unique words in Shakespeare. Already, we've covered 2 of the major themes of the course. One is functions, such as len, or open. Another will be objects. Set is an object. It represents and behaves like the set of all words in Shakespeare. And finally, we have the programming language itself, which is how we're expressing this information and what's being interpreted by the computer in order to give us the results that we see. Everything I've typed so far is an expression. And some expressions we saw are things that are very simple, like draw, but we can also have expressions that contain operations. What you see here is a shorthand for reversing a word. So draw's reverse is ward, W-A-R-D. Now we can use this operation that reverses a word in combination inside of a bigger expression. So I could get the set of all W for the W in words if it's the case the W is the same as its reverse. And the length of W is greater than 4. And we get all the words that are the same backwards and forwards: level, refer, madam, and the longest one, redder. We can also use another combination, every W for W in words, if it's the case that the reverse of W is also in words, meaning the reverse of the word W is also a word. And let's say we only want the ones that have length exactly 4. Well, look at all those. Rail and liar are opposite. Evil and live. And this does contain anything that's the same, forwards and backwards. Do we think there are any of length 5? Well, certainly there are. How about length 6? Redder, reward, diaper, drawer, and repaid. Okay, so repaid is diaper backwards, and drawer is reward backwards, and redder is the same, forward and backwards. Anything bigger? No. Now, why is that? Well, it's because we're dealing with a vocabulary of only a mere 33,000 words. But what if we had more words? We can get that. We can actually change the set of words that we're talking about to be the set of all words in some big dictionary. Here's a path to a big dictionary on a Mac. We'll read that in and split it into individual words. So what's new now? Now we have more words than we had before, 235,000 different words. Now we have things like computer in the words, and that wasn't in there before. So, what happens if now we look up all the different words, W for W in words, if the reverse is in words and the length is equal to 6? This is the same expression I had before. But because something has changed, namely what the set of words is, we find all sorts of new stuff. There's redder, just like before, but now we have new words, like retool and looter. And if we look for ones that are longer than 6, we find there are some there as well. Longer than 7, down to only 1. Rewarder and redrawer are the 2 words that can be spelled backwards and still be in the dictionary, for the dictionary that's built into the Mac. So you can work through this example yourself and see what happens. Don't be afraid, you won't hurt your computer. And if you go to composingprograms.com, you'll see how to download the entire works of Shakespeare from the web so that you can play around with it just like in these examples.